Okay, folks, there's a question about relative min, relative max, extreme max, extreme minimum. Let's see if we could get this video and explain these concepts. Okay, here we go. All right, so here's a XY graph. Okay, how about we do blah, 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 blah. Okay, let's draw a function here, okay? Let's draw a nice little function. So let's say I've got a point here. I'm going to go up here. I'm going to go down here and here. Okay. Now let's identify some points. Okay. Let me do that in a different color. All right. So this point right here is going to be a -2, -4. Okay. This point right here is 1, 1. This point right here is going to be 3, -2. Okay. Now the question is, does this function have a minimum? When we're saying minimum is, let's make believe that this function represents the height of a river, back in time a little, back 2 hours and forward a few hours, okay? So a minimum is, we're looking for a y value that's further toward the bottom. The only y value that's furthest to the bottom, the y value stops right here. So that is called an overall or extreme minimum. Extreme minimum. Now, what is the minimum? Now remember, the minimum are the y values, so the minimum would be -4. Okay? All right. Now, my next question is there a maximum? Is there a maximum for the overall function? Well, the question is, what does this arrow mean? That arrow is representing it continues forever. So is there a maximum? No. There is no overall or extreme maximum here. Now the question has to deal with, are there local minimums and maximums? So when we say loco, not loco, but local, okay, we're looking in this green circle. The way I teach this is I have everybody in my class stand up, okay? Everybody stands up. And then I find in my class who is the shortest, okay? I call her Minnie. And then I got whoever the dude's the tallest here, okay? I call him Max. Max and Min, okay? Now, are they the shortest person in the university? No. But in our local group, relative to each other, you know, that person is the shortest. In our local group, that man is the tallest. So meet Max and Min. Now the question is, as I'm looking at my function, okay, the function, like, it continues up here and then it turns, right? So this point right here is a maximum, not an overall maximum. It's a relative maximum. What do you mean by relative maximum? Relative to the values surrounding it. Just like in my class here, that dude, the tall dude, he's not the tallest altogether, but relative to everybody we're looking at, okay, he is the tallest. Now the question is there a local or relative max? Yes, there is. What is the relative max? Okay, why, he is 1. That's the y value. Where does that happen at? The location of the relative max is at 1, 1. All right, let's look at Minnie right here, okay? All right. Now, she was the shortest, okay, but not the shortest in the university, right? Okay. Please tell me what was the value of the relative min. The value of the relative min was -2. Please tell me what domain value that happened at. Or in other words, what hour mark was the water the lowest, okay? And so that would be the domain value or x equals 3. If I asked you what's the location of the relative min, you're going to say 3 comma negative 2. Okay? All right, let's pause that. Okay, so with all of that information in our minds, let's look at a question or two from the 10.2 assignment that we had a question about. Okay, now try to get my little tool over here, okay? All right, so what we're doing is this is going to be a absolute minimum. The function stops there. That's the lowest part of the function, okay? And that's this level right here. And let's look at a maximum. Here's a maximum right here, okay? All right, so okay, I'll just draw that. Now, the question is, are there any local minimums? Here's a local minimum here, kind of like the bottom of a valley. And it does appear like there's a local maximum here. Now, let's do this. Let's actually put the numbers here. What is the value of this minimum, this point right here? That's negative 4. So y, what's I just messed up? That's negative 5, okay, is the y value right there. What is the y value here? The y value here is 4. What's the y value here? The y value here is negative 1. What's the y value here? The y value is 3. What's the y value here? The y value is 1. All right, now the question is there an absolute minimum? Yes, there is an absolute minimum. It's the lowest or most negative value. That is negative 5. Is there an absolute maximum? I don't know. Does the function go up forever? No, it stops. Okay, now it stops at 3 and it stops at 4. But which one's the highest? 4. Okay, so this is absolute minimum. This is absolute maximum. Now, are there any relative mins or relative maxes? Well, yes, there are, okay? So meet mini over here. Here's mini, okay? That point right there. And what's its value? Negative 1. And how about max? Do we have any strapping young lad football people or basketball people? Yes, we do, okay? And so what is the relative max? The relative max right here is 3, okay? So meet max. All right, now let's go and review this a little bit here. What's the domain value of the absolute minimum? That domain value is, what is that? Negative 5. Okay, right, negative 5. Okay. What's the domain value of the absolute maximum? I don't know, let's see, that's negative 3. What is the domain value of Miss Minnie? Oh, that's 0. What is the domain value of Mr. Max? 2. Okay, and this is really not anything right there. All right, so now with that in mind, can we answer the questions? Can we answer the question? Oh, I can't believe I don't have my pick. Okay, so let me make sure we got that, okay? This is the absolute minimum. This is the absolute maximum. This is relative minimum. This is relative maximum. And the brown numbers are the x values and the blue numbers are the y values. Okay, now let's look at the question here. All right, number whatever, okay? Let's get a color here. All right, list the local minimums, if any exist. Okay, not absolute, but local, so that's a relative min. Here's a relative min. I wouldn't really use this one, okay? I would just use this one right here. And what is the relative min? It's negative 1, and it happens at 0, negative 1. All right, find the minimum if it exists. Now, the minimum, so this is overall. It should have said, it would be better to have the word absolute or extreme. So this point right here, okay, this point is the absolute minimum. Now, the absolute minimum is a y value, so that's negative 5. Okay, take a look at that picture. Make sure that that's clear. Okay, I hope that cleared up that problem, and I do apologize for that video being a little messed up. Um, hey, I'm doing the best that I can. Well, contact me if you have more questions. Thank you.